On this DeBacco University video, I'm going to give you a brief overview of the main components of an atom, going beyond just the electrons, protons, and neutrons, also breaking apart even what they're made out of, quarks and leptons. So hopefully you enjoy this deep dive into the components of the atom. All right, if you're looking for a slide to kind of screenshot and try to go over multiple times, this would be the one. These are the main components of the atom: the protons, neutrons, and electrons. So the proton has a positive charge. It kind of helps you remember that. It's got a relative mass of 1 atomic mass unit, and it's located in the nucleus. In comparison, the neutron is neutral, or has no electrical charge, also has a relative mass of 1 atomic mass unit, and is found next to the protons in the nucleus. The electrons have a -1 charge, relative mass of 1 over 1,800 AMUs. A lot of times we consider this to be about 0, particularly when we do math equations. We just kind of neglect them because of their very, very small mass, but they still do have a mass. And they orbit around the nucleus there, which is containing our protons and our neutrons. So protons, neutrons in that dense nucleus, electrons with their negative charge orbiting around that. Now the protons specifically, when we look at this in more detail, they carry a positive electrical charge, equal in magnitude, but opposite to the negative of the electron. If you want to get to the exact mass, this is the exact mass. It's roughly 1,836 times the mass of an electron. It's slightly less than a neutron, but for the most part, we consider them to be equal proton and neutron masses. The protons do reside in the atomic nucleus, surrounded by a cloud of electrons orbiting at a distance there. The composition of a proton, they're not fundamental particles, but they're made up of smaller fundamental particles called quarks. Specifically, a proton consists of 2 up quarks held together by a strong nuclear force mediated by gluons. Now, 2 quarks, each with a charge of plus 2/3, and 1 down quark with a charge of -1/3. So if you take these 2 up quarks and those 1 down quark, that essentially gives you the proton with a net positive 1 charge. We could see there, here's our proton, and we're going to talk about the neutron going forward, but this kind of gives you an idea of the 2 up quarks and 1 down quark. We see that here, and our neutron will be slightly different. So the role of that proton, well, the protons along with neutrons form the nucleus of an atom. The number of protons in an atom's nucleus determines the atomic number. Very important here because that defines the element. So for example, 1 proton is hydrogen, 6 protons is carbon. If it had 2, it'd be helium, so on and so forth. This was discovered here by Ernest Rutherford with the gold foil experiment. So very important subatomic particle here that makes up the atom. Now the electron, it's another subatomic particle that orbits around the nucleus, as you kind of see here, shown by the what looks like light kind of going around. Electrons do carry a negative electrical charge, equal in magnitude, but opposite to that of the proton. The mass of an electron is very, very small, essentially 1 over 1,836 of a proton or neutron, making it extremely light, making it basically a lot of times neglected in most simplified mathematical equations, and they orbit the outside of the nucleus on varying energy levels. The composition of an electron are basically their fundamental particles, meaning they are not made up of any smaller particles, so light themselves and small. That an electron is simply just an electron. Slightly different with our protons and our neutrons, as I'll describe here in a moment. So what's the role of the electron? Well, electrons occupy regions around the nucleus called orbitals, and they form the electron cloud. J.J. Thomson's discovery is the one who kind of identified them. The number and arrangement of electrons does determine an atom's chemical properties, such as its relativity, as well as its bonding behavior. Its location, again, those orbitals around the nucleus, charge is basically -1 as far as we're concerned, and the mass is very, very light, sometimes often neglected in mathematical equations. Now the neutron, this is a subatomic particle that's found in that nucleus, and the charge is electrically neutral, meaning there's essentially no electrical charge. It does have a mass slightly greater than that of a proton, but for our purposes we consider them to be equal, but much, much greater than that of an electron, approximately 1,839 times heavier than a single electron. The location is neutrons reside in that nucleus alongside protons in that core dense portion of the nucleus of the atom. The composition of our neutrons, so you might recognize this picture from the protons, but neutrons are not fundamental particles. They're made up of smaller particles called quarks. Specifically, a neutron consists of one up quark and two down quarks held together by strong nuclear forces called gluons, as we saw with the proton. So if we do the math here, we have one up quark with a positive 2/3 charge and two down quarks with a negative 1/3 charge. Essentially 2 times this plus this essentially results in a neutral charge, or essentially no charge there. So that's why neutrons, as a way to remember them, are neutral. Now the role of the neutrons, you think that's neutral, doesn't really do much. Well, it works alongside with protons. In that nucleus of the atom, the number of neutrons determines the isotope of that element. And neutrons do contribute to a nucleus's mass, stability, helping counterbalance the repulsive electromagnetic forces between positively charged protons. They're kind of in there, almost consider them as mediators. Also, those ions are really important. You might see carbon-12 has 6 neutrons, while carbon-14 has 8 neutrons, because in order for an element to be an element, it has to have the same number of protons. But if we adjust the neutron number, we're adjusting the mass and also the isotope of that element. And James Chadwick was the one who discovered these particles. Now, I've talked a little bit about these, but these quarks are fundamental subatomic particles that form the building blocks of protons and neutrons, as well as some other particles. They exist within composite particles like protons and neutrons, and reside within the nucleus. Their behavior is governed by the quantum chromodynamics, the theory describing the strong force that does exist between them. Now, the charge and the mass of a quark here, quarks carry functional electrical charges either as a plus 2/3 or a negative 1/3 of an elementary charge. Up quarks are the positive, down quarks are the negative. Then there's other types that have, fractional charges as well. We're going to focus mainly on the up and down quarks as it relates to protons and neutrons. Quarks are extremely small masses, but their exact masses are complex to define due to quantum effects. So that's why we just focus on the masses there of the protons and the neutrons. The composition here, well, they're fundamental particles of the standard model of particle physics, meaning they are not made of smaller constituents. They combine to form composite particles like protons and neutrons. We see here another here of the protons having the 2 up quarks and 1 down, or the neutron having 2 down quarks and 1 up quark. The role of quarks here in the atom, they're not really directly found in atoms, but are the constituents of those protons and neutrons, which form the atomic nucleus. They're held together with these particles as a strong nuclear force called gluons, as we can see here. Kind of think them as the joining kind of function there of tying everything together to make that proton or to make that neutron. Then there's also something called leptons here, which is a fundamental subatomic particle that belong in a family distinct from quarks. The location is electrons exist in orbitals around those nucleuses that are dense and made up of protons and neutrons. Other leptons, the muons, taus, are typically produced in high-energy processes such as cosmic rays, particle accelerators, nuclear reactions, but these are not part of stable atoms there. Now, the charge and mass, the leptons can be negatively charged or neutral. The electron has that -1 elementary charge. There are neutrinos, which again have, as the name implies, a neutral charge. Other leptons can have a -1 charge. Some are associated with neutrinos and are neutral. They get a little more complex. We're just going to keep this as a basic overview. The mass of leptons range in masses, so we're just going to kind of not get into the, quote, details of them for this overview of the atom. Now, the composition of them is that they are fundamental particles, meaning they are not made of smaller constituents, unlike we saw with the quarks making up our protons and our neutrons. Instead, we just have that lepton, which is essentially an electron. Lastly here, the role of these leptons is the electron is a type of lepton. As it orbits the nucleus in the electron cloud, it helps determine the atom's chemical properties and balancing the positive charge of those protons. Neutrinos and other types of leptons don't play a direct role in the atomic structure, but are involved in processes like nuclear reactions, such as beta decay. So you can see something that's very small can still be very complex when you start diving into some of the details, but having a bigger picture of understanding those protons, neutrons, and electrons, and then understanding kind of these particles that make those up will give you a full overview of what makes up an atom.